a question here. So this is the finding C, which is the skill for today, really. So we get questions something like this. They'll give us a derivative either using dy dx or f dash, and they'll say the gradient equation is that, and then they'll give as well some point that we know it goes through. Now, there's two steps. Step one is just what we practiced yesterday, and that is just to do the normal integration. We should add in, to be polite though, a plus c, and I'll give you the logic behind that, because if I go to here and I put in y equals, and I go 2x squared, that's a start, minus 4x, I get that. And if I put in plus c, on good old Desmos, I can put a slider. So if I had a slider in my paper, obviously I could solve this, because if I look at the slider, if I move it up and see, there is my answer there. Okay, because 2x squared minus 4x plus c, it's not changing shape, but it's definitely, the c is just moving it up and down. So I want to know how big the c is. If I can look at it visually like this, I can do the answer, but I need to be able to do that algebraically. So the equivalent of getting the slider going and finding the answer is step 2. And basically we sub that coordinate 2, 8 in. So if I've got a bit of working here, all going well, if it's shown up. Don't think I quite got it all there, so I'll try again. So if I show this up, this is the working. So f of 1, now that's a mistake, that's meant to be f of 2. So I take 2 and sub it into this equation anywhere where there's an x. 2 times 2 squared minus 4 times 2, and I leave the plus c in, but I add to it equals 8, or equals the y value. Okay, then I chop that f of 2 off, and so I just start tidying up. 8 minus 8 plus c equals 8, so that's just all of that. Neat it up a bit. Based from there, it becomes quite tidy in this case. C equals 8, and then the final job is I write the correct equation here. Now over here, that would be the equivalent of going back on there and just saying, oh, it's 8. I wouldn't need the slider because I've got the solution, because that equation has that as its gradient function. If I differentiate it, I get that. And it goes through 2, 8. So I've satisfied it. Okay?